Bismillahirrahmanirrahim. So we were talking about the higher degrees, and we gave the first fundamental theorem of algebra, which says that every polynomial of degree at least one has a root in complex numbers. And then we have built some theory, and it says that in theorem 7.2 that every polynomial of degree n factorizes as a product of linear polynomials and has exactly n roots in complex numbers. Then we talk about the real polynomials, and theorem 7.3 says every real polynomial factorizes as a product of real linear and real quadratic polynomials and has its non-real roots appearing in complex conjugate pairs. You can show that by taking an example, just say of a quadratic equation or a cubic equation, and then you can see. Okay, now we will talk about, in this part, relationship between the roots. Okay, now despite the fact that there is no general formula for the roots of polynomial equations of degree 5 or more, there are still some interesting and useful relationships between the roots and the coefficients. Now let's consider the quadratic equation. So let's say we have x square plus ax plus b is 0. Sorry, yeah. And if alpha beta are the roots, if alpha comma beta are roots of this equation, then we can say that we can express this equation as follows: as the product of linear polynomials. And if you further explain this, you will have x square minus alpha plus beta into x plus alpha into beta. Hence, equating coefficients we have, by equating the coefficients, both sides, what we will get? We will get that the sum of roots is minus a, and the product of roots is b. Now, maybe from the previous literature, you might know something different for these minus a and a, because you have coefficient a with the x square, b with the x, and c with the as a constant. But like, look at this equation. This equation doesn't have any coefficient with the x square and just have with x and as a constant. So that's why you have different coefficients appearing as a sum of roots and the product of roots. Likewise, consider the cubic equation. X cubed plus ax square plus bx plus c is 0. And let alpha, beta, gamma are the roots. Then we have x cubed plus alpha x square plus bx plus c can be written as x minus alpha, x minus beta, x minus gamma. Then by equating the coefficients, we can write what? We can write that alpha plus beta plus gamma is nothing but minus a, alpha beta plus alpha gamma plus beta gamma is B, and then alpha beta gamma is minus C. And you can show that for every for every quadratic, like cubic polynomial or equation. Okay, polynomial equation. Then we can talk about and give a very interesting proposition. 7.1, which says that let the roots of the equation this x power n plus an minus 1 x power n minus 1 plus a1x plus a naught is 0, b alpha 1 alpha 2 up to alpha n. Now if S1 denotes the sum of roots, S2 denotes the sum of all product pairs of roots. We are talking about, in that case, we are talking about this. This could be S2, comma, S3 denotes the sum of all products of triples of roots, and so on. Then, what can we say about the roots? Then, we can write S1 is alpha 1 plus alpha n, which is nothing but minus a n minus 1. We can write S2 is a n minus 2. We can write S3 is minus a n minus 3. And if we go down further, we can write Sn is the product of all the roots. And there is nothing but minus 1 power n a naught. And we have proved this for the cubic equation, but like we can give an actual proof for this. So for the actual proof, let's say we have x power n plus a n minus 1, x power n minus 1, have this polynomial. And this can be written as the product of all these linear equations, polynomials. If we multiply out the right hand side, the coefficients of x power n is if we multiply the right hand side, the coefficients of x power n minus 1 is what? Minus alpha 1 plus alpha n, which is nothing but minus s1. Similarly, the coefficients of x power n minus 2 is s2 and so on. Then by this, the result will follow. And let's do some examples. So we write down a cubic equation with the roots. So we have the roots, and we need to find or write down the cubic equation. So example. So write down a cubic equation which has roots 1 plus iota 1 minus iota and 2. Remember, roots are in conjugate pairs. So solution. So let's say we have 3 roots. Let's let alpha 1, alpha 2, and alpha 3 are roots. Then we know that S1 is going to be sum of them. And if you sum all these 3 roots, this will be 1 plus iota, 1 minus iota, plus 2, and this is going to be 4. Now S2 is going to be product of 2 pairs. And if you solve this, you will get 6. And S3 is going to be product of triples. So there are only 3, 1, 2, and 3. And then product of all these is 1 plus iota. Product of all these, 1 minus iota. And into 2 is nothing but 4. So hence, we will get the cubic equation, which is x cubed minus 4x square plus 6x minus 4 is 0. Now, you can try these combinations and then find out the cubic equations in general. Now, let's say this was the example 1. Let's say we have number 2, which is that if alpha, beta are roots of the equation x square minus 5x plus 9 is 0. Find a quadratic equation with the roots. Find a quadratic equation with the roots alpha square, beta square. This is not tricky. This is the simple one. You know that the sum of roots alpha plus beta is going to be 5, because this is minus s1, so minus is already here in the equation, so that will be 5 only, and then product is the constant 9. So what you can do is just do alpha square plus beta square, which is alpha plus beta whole square minus 2 into alpha beta. And if you solve this, you will get 5 square minus 18, that is 7. So the sum of these two roots is 7, and then alpha square beta square is nothing but 9 square, so this is 81. So we can write that if the equation have alpha square and beta square as roots, then that equation will be x square minus 7x plus 81 is 0. Right. Number 3 says that find the value of k if the roots of the cubic equation x cube plus x square plus 2x plus k is 0 are in geometric progression or in geometric progression. Now for this term you need to learn somehow the sequences and series. So there is a geometric sequence, and then we need to follow that rule of that geometric sequence for the roots. So how? So let's say we have alpha is a one root, then we will have alpha r is a second root, and then alpha r square for some r. So if the roots are in geometric progression, they will be like this. Then we have alpha into 1 plus r square, which is nothing but minus 1, and alpha square r plus r square plus r cube is 2, and then alpha cube plus r cube into r cube is minus k. So we follow this procedure. Dividing the first two of these gives that alpha r is minus 2, hence k is 8. K is 8. That's the solution. That's it for today. Thank you so much. Bye-bye.